This is chapter 6, problem number 34. In a high jump, the kinetic energy of an athlete is transformed into gravitational potential energy without the aid of a rope. With what minimum speed must the athlete leave the ground in order to leave his center of mass 2.1 meters and cross the bar with a speed of 0.5 meters per second? Okay, so let's analyze it. This person, okay, what he wants to jump, the height, he wants to jump to the height of h equal to 2.1 meter. Okay, over here at the highest point, it should be more than 0.5 meters per second. Okay, or it should be at that speed. It's not zero. Okay, so the question purposely asks for at this point it should be 0.5 meters per second. Okay, so let's analyze it. He's moving over here. When he is over here where h is equal to 0, okay, initially, so kinetic energy is moving, so half mv initial square, half mv square, so that is the kinetic energy. Potential energy is 0, so we can ignore that term. That will be equal to kinetic energy at the final, half mv final square, plus the potential energy, and that is mgh. That means, let's look at this one. The m can be cancelled out. That means it's independent of the mass. Okay, so what I'm going to do is I want to solve the v initial. Okay, so this is what I'm going to do. I'm going to isolate. Okay, I'm going to multiply both sides by 2. So v initial square, that is equal to v final square plus, I multiply by 2g times h. V initial square will be equal to V final square, that is 0.5 square plus 2 times 9.8 times 2.1. Okay, so that is equal to 0.5 square plus 2 times 9.8 times 2.1. And then take a square root. Okay, so what I see over here is initial velocity, it should be 6.4 meters per second. Okay, all right, I'm going to check, see if I have everything correct. Okay, 6.4, so I put in here half times 6.4 square. Let me see what it is. So this number square divided by 2. So there's, okay, so on the left side I have 20.7. Okay, because it's energy, so the unit should be joules. Let's check this one, the final one, that is equal to half times 0.5 square. So 0.5 raised to 0.5 in final, 0.5 raised to, 0.5 raised to divided by 2, 0.125 plus 9.8 times 2.1, 20.58, so 20.58. Okay, so when you add this up, yes, it's close to 20.7, so we are correct. Okay, the lucky number for this problem is number 8. Okay, number 8, that will be our lucky number.